$4 billion. That is what it costs to launch the Space Launch System once. Not to build it, not to design it, to light the engines, watch it climb, and then watch every single piece of it fall into the ocean, never to be used again. $4 billion. Gone. Per flight. And 3 days ago, it worked perfectly. NASA will tell you the SLS is the backbone of the Artemis program, the most powerful rocket ever certified to carry humans, a marvel of American engineering. And that's true. But it's about 15% of the truth. Because if you zoom out past the mission patches and the press conferences, what you find is something stranger and more interesting than a rocket. You find a civilizational argument playing out in real time. An argument about how a government makes the transition from one era to the next without dropping the people in between. An argument that, as of February 2026, just got a great deal more complicated. Here's what this video is actually about. Why NASA is deliberately flying a $4 billion disposable rocket when a $100 million reusable one already exists. Why Artemis III is no longer going to the moon. What a crude docking test in Earth orbit actually reveals about the plan behind the plan. Why the most important question in American aerospace right now isn't technical, it's political. And what happens to human spaceflight if SpaceX proves one more thing in the next 12 months. To understand why the SLS still exists, you need to meet a program that was never really just a rocket. The SLS began life in 2010, assembled from the bones of the canceled Constellation program. Built using the same engines from the space shuttle, the same manufacturing plants, the same workforce. Huntsville, Alabama, Michoud, Louisiana, Stennis, Mississippi. By design, the economic footprint of the SLS was spread across all 50 U.S. states. Every senator has a constituent whose job touches this rocket. That is not an accident. That is architecture. Political architecture, built to make cancellation functionally impossible. But here's the thing, the SLS also works. Artemis I flew flawlessly. Artemis II, which just returned its 4-person crew 3 days ago, worked. The Orion capsule has been safety certified for human flight through a decade of testing so exhaustive it fills rooms of documentation. The SLS can launch Orion on a direct trajectory toward the moon in a single shot. No waiting, no assembly in orbit, no dependencies. You fuel it, you light it, and it goes. That matters more than the price tag suggests. Because what NASA is really buying with $4 billion is not a rocket. It's a guarantee. A certified, tested, legally defensible promise that the 4 people sitting in that capsule will not die due to a process the agency hasn't verified 1,000 times over. The implication is this. In human spaceflight, redundancy isn't waste. It's the product. Here is where it gets genuinely strange. 12 miles from the SLS launch pad at Kennedy Space Center, SpaceX is preparing to fly Starship for the 12th time. Starship is, by every objective metric, the more capable vehicle. It's fully reusable, both the booster and the spacecraft. Its target cost per launch is $100 million, a number that, if achieved, would make the SLS look not just expensive, but almost absurd. It can carry more mass to orbit than any vehicle ever built. And yet, Starship cannot currently launch a crew from Earth to the moon on its own. The reason is physics, and it is not a small problem. Starship is so heavy, the fuel it needs to leave Earth orbit so enormous that it requires more than 10 separate tanker launches to fill its tanks after reaching orbit. 10 launches. Each one a complex orbital rendezvous. Each one another opportunity for something to go wrong. Before a single astronaut climbs aboard. NASA is not willing to stake a human crew on a chain of 10 sequential successes with technology that has never done it before. Not yet. That is not timidity. That is the engineering definition of the word not yet. So they built something else, a hybrid. The mission that Jared Isaacman announced in February 2026. He was confirmed as NASA Administrator just weeks earlier, a former fighter pilot and the first private astronaut to conduct a spacewalk, a man who has actually been there. That mission is not what most people expected. Artemis III is no longer a lunar landing. Read that twice. The mission that was supposed to return human beings to the surface of the moon for the first time since 1972 has been redesigned as a crewed Earth orbit docking test scheduled for mid-2027. The moon will have to wait. Here is what Artemis III now actually looks like. SpaceX launches an uncrewed Starship human landing system into Earth orbit. It waits. Then, NASA launches 4 astronauts inside Orion on top of the SLS. In orbit, Orion finds Starship and docks with it. The crew transfers. They spend time inside Starship, testing the life support, the controls, the docking mechanisms, the systems that will eventually carry people to the lunar surface. Then, they move back into Orion, and Orion brings them home. Because Starship is not yet certified to return humans through Earth's atmosphere. 2 rockets, 2 companies, 1 mission. Neither one capable of doing it alone. The implication here is structural. NASA isn't choosing between old and new. It is running them in parallel, using each for the one thing it does best and hoping the handoff doesn't kill anyone. There is one more layer, and it may be the most consequential one. The 2026 federal budget proposal contains language that, in any other year, would have made the front page of every newspaper. There is a serious, well-funded push to cancel the SLS after Artemis III. Not after Artemis V, not after the Gateway lunar station is complete, after the next crewed mission. The argument is straightforward. Starship V3 is becoming so capable that every mission the SLS currently performs will soon be achievable by a fully reusable system at a fraction of the cost. The Gateway station, NASA's planned outpost in lunar orbit, was always going to require SLS launches to assemble. But if SpaceX can demonstrate reliable orbital refueling in the next 12 months, that calculus collapses. You don't need the SLS to build Gateway if Starship can do it cheaper, faster, and in larger pieces. $4 billion per launch, $100 million per launch. That is not a rounding error. That is a factor of 40. Here is the geopolitical dimension that makes all of this urgent in a way that budget discussions usually aren't. China's ILRS base at the lunar South Pole is on track for 2035. China is not debating the philosophy of reusability versus reliability. China is building. Every year, the SLS debate drags on in Washington. Every continuing resolution that delays the program, every budget fight that shaves a mission. That is a year China doesn't waste. The question isn't whether America has the better rocket. It's whether America can make decisions fast enough to matter. The astronauts who splashed down 3 days ago spent weeks inside the Orion capsule. They were kept alive by systems certified over a decade. They came home because the $4 billion rocket worked exactly as designed. And somewhere in a SpaceX facility in South Texas, engineers are preparing Starship Flight 12. Those two things are not in opposition. They are a relay race. The SLS is running the first leg. Starship is waiting at the exchange zone, hand outstretched. Not quite certified, not quite ready, but getting closer with every test. The real question of this decade isn't which rocket is better. That answer is obvious, and everyone knows it. The real question is whether the institution that spent 60 years learning how not to kill people can move fast enough to hand the baton without dropping it. Whether a government program built across 50 states and a generation of careers can gracefully become something smaller, cheaper, and faster. Whether the word proven remains an asset or becomes an excuse. The rocket that costs $4 billion is sitting on the pad right now. The rocket that costs $100 million is about to fly for the 12th time. One of them is the past. One of them is the future. For a few more years, we are going to need both.